show that the points A1, B1, A2, B2, and A3, B3 are collinear provided the lines whose equations are given to us, these three lines, are concurrent. Okay, let us begin. Now, what we'll do, we'll start with the three lines. So here we have the line L1 with equation A1x plus B1y plus 1 equals to 0. Then we have the next line L2. L2 has got equation A2x plus B2y plus 1 equals to 0. And then we have the third equation of the line given by A3x plus B3y plus 1 equals to 0. Okay, now it's given here that these three lines are already concurrent, and we know the property of concurrency suggests that if we have three lines that are concurrent, then we're going to form a 3 by 3 determinant which is going to have a value equals to 0. Now how do we form the 3 by 3 determinant? So we have the rows R1, R2 and R3. So these are going to be the three rows, and then we have L1, then we have C1, C2 and C3. These are going to be the three columns. So starting with line number 1, so all the constant coefficient terms a1, x1 and y, they are going to get placed in row number 1. So in the first row, first column, we use a1, so that's the coefficient of x. Then in the first row, second column, we will use b1, the coefficient of y. And then in the first row, third column, we use the coefficient, the constant coefficient term, that is 1. So similarly, in row number 2, we're going to use the constant coefficients of line number 2. So we have a2, b2 and 1. And then in the third row, we use L3. So we have A3, B3 and 1. And this is the condition for concurrency of line L1, L2 and L3. However, this particular determinant also tells us that the points with coordinates A1, B1, A2, B2 and A3, B3, these 3 points are collinear. So are collinear. So it's a very straightforward form we are given here. So whenever we have three lines L1, L2 and L3, first we form the 3 by 3 determinant, equate it to 0. So the 3 by 3 determinant is formed by taking the coefficients of each of the variables including the constant term, and then the condition automatically gives us the condition for collinearity of 3 points whose coordinates are A1, B1, A2, B2 and A3, B3. Hence proved.